Okay. Now back to action. I don't know where we were. How do these things affect rate of solution and how do they do it? How's temperature affected? Temperature goes up, the rate of solution should go up. Why? Particles are moving faster and touching the solvent more often. Yeah. Nature of the substance. That one's real easy. Very simply, some things just react faster than other things. Agitation. The more you stir it, the faster because you're letting the solute and solvent contact each other more often. Surface area. The more surface you expose, the faster the solution happens. So in that case, real simply, smaller pieces have more surface area. Okay. How are boiling point and freezing point changed by dissolving a solute in a solvent? Anybody remember what happens? What happens to the boiling point? You dissolve solute in solvent, boiling point goes up. Very good. It gets elevated. Freezing point gets lowered. Yeah. So when they put the salt on the roads, drops the freezing point, it has to be colder temperature before the ice will freeze. Use the PV equals nRT equation or some form of it. The example I used here was the old Mr. T equals the MVP kind. In this case, MVP is Mr. T. So we're trying to find molar mass. So it'd be Mr. T over the VP. So we have 1.95 grams. R is 0.0821 liter atmosphere over mole Kelvin. Temperature is 300. Volume 1 liter. Pressure 1.5 atmospheres. And boy, I do not remember what the answer is to this one. $32 grams per mole. How do we get the number of valence electrons? Well, it seems like I'm missing some. I guess not. How many for chlorine? How many? 7. Hydrogen? Bromine? Phosphorus? Magnesium? Neon? 8. So family number in Roman numerals, or if it's the Arabic numeral, subtract 10 once you get beyond column 10. So 717528. Pretty easy. I give you 4 numbers there. Pick one of the 4. Unless there's 5 choices, which couldn't tell you on that if there would be or not. Now, properties of ionic and covalent molecules a little bit different than the first thing that we talked about of what kinds of things are in them. So what kind of properties do we have? Well, we know that ionic compounds have high melting points, dissolve in water usually, conduct electricity when they're dissolved or molten. Covalent, low melting point, don't dissolve in water usually. If they do dissolve, they don't conduct electricity. Dilution problems we just got finished with on our quiz. You had to do M1 V1 equals M2 V2. Some of you missed these on the quiz, needless to say, because you do your algebra upside down. 250 milliliters, 3 molar, dilute to 750 milliliters. Well, 3 times 250 is 750. Divide both sides by 750. I got 1 mole per liter, or 1 molar. Now, you know what? On that problem, if you look at it, you went from 250 to 750. You tripled the volume, kept the moles the same. So your, whatever you call it, molarity ought to be 1/3. What's 1/3 of 3? 1 molar. Next one said, calculate the mass of solute needed to make 250 milliliters of a 2 molar solution of 2 molar LiNO3. So you have to take the molarity times the volume, and in this case, it must be in liters. So I took the 2 moles per liter, I multiplied by 0.250 liters, and I got a half a mole. Then I take the half a mole and I multiply by the molar mass of LiNO3, which turned out to be 68.9 grams per mole. So a half of 68.9 is about 34.5. Something like that. And there's the magic code for the entire test. Just remember that. I don't know what that means. You'll have to probably do a couple of these, couple formulas. There you go, Bailey. Who is that? Lemmy. Calcium nitrate. Calcium, 2 plus, nitrate, -1. Magnesium, 2 plus, chloride, 1 minus, sodium, a +1, sulfide, a 2 minus, copper, a 2 plus, sulfate, a 2 minus. So now we can cross our charges. And you know what I'll do. I'll put down every bad combination I can of them. Cross charges. This one, you know I'll make it 2-2, but you only need 1 of each. So we're going to wait 16 seconds and let this thing run out. And hopefully we'll have another copy.